All right, Algebra 2 guys, this is the section on series. Remember, this is the really short chapter / unit because all we're talking about is sequences and series. So we talked about sequences where you're trying to find the order of a set of numbers. You're trying to figure out, are you adding and subtracting over and over again, or are you multiplying and dividing over and over again? Now we're going to take that a step further, and the only difference between a sequence and a series is this. In a series, you are adding up all the terms, okay? So on a sequence, you're just trying to figure out what the terms are. In a series, you are adding up a certain number of terms. So we take a look at the problem. The first row, can seat 18 people in the first row, and each row can seat 4 more people than the previous row. So find the number of people who could sit in the first 5 rows. So if I let this be kind of my first term, this is kind of my common difference. So the first 5 rows would be 18, 22 in the second row, 26 in the third row, 30 in the fourth row, 34 in the fifth row. So that would be a sequence. The series says add all those up. So add 18, 22, 26, 30, 34. So that's going to be 130. All right, so let's keep going here. So, story time. In the late 1700s, Carl Friedrich Gauss was a student at a small German schoolhouse. Gauss was a bit of a troublemaker, and the teacher was fed up. As a punishment, he made Gauss go sit in a corner and add up the first 100 integers with the thought of this being a very lengthy and tedious task. Gauss finished within seconds. So how did he do it? Well, he ended up doing what is called an arithmetic series sum. So focus more on this one. This one has a lot of bits and pieces to it that will really confuse you. The second one is a little bit more handy, and here's kind of what it is. The sum of the first n terms, okay, so if it's 10 terms, it's 10. If it's 15 terms, it's 15, is going to be the number of terms divided by 2 times the first term plus the last term. All right, and we figured out how to figure out those terms in sequences. So the sum of n terms is going to be n divided by 2, first term, nth term. Okay, so take a look. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? So where do we start? So we're looking for the sum of March in, so we're actually given the sum. We're trying to figure out how many push-ups did Aiden do on March 1st. All right, so first off, we got to look at how many days does March have. All right, so March has got 31 days. So now he did a total of 1,085 push-ups. So 1,085 push-ups, March has got 31 days. So n is going to be 31. The sum of 31 days is going to be 1,085. All right, so to set this up, I'm going to have 1,085 equals 31 divided by 2. Now, I don't really know my first day. That's kind of what I'm looking for. But if I increase every day by 1, then that means that this is going to be so on the first day he does X. Okay, so on March 1st, he does X push-ups. On the second day, he increases 1, so he goes X plus 1. On the third day, he goes X plus 1 plus another 1, so it's like X plus 2. So on the fourth day, he's going to go X plus 3. So now on the 31st day, so on March 31st, by the time you add all these up, he's going to do x plus 496. What that comes from is 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way through. So 1085 is going to be equal to 31 divided by 2 times 2x plus 496. So a little solving there. 31 divided by 2. Oops. Times 2 is 31x plus 768. Okay, let me back up because I made a mistake and it happens. Remember, on the 31st day, we're looking for how many push-ups he did on that day. So on the 31st day, he did x plus 30 push-ups. Sorry, not 496. 496 would be what you would add up if you added up all the days from the second day all the way up to the 31st day. So on the first day, he does x push-ups. Second day, x plus 1. Third day, x plus 2. Fourth day, x plus 3. So the pattern is you're adding on one less than the actual date. So it's going to be x plus 30. So you get 2x plus 30 here. So when you do that, you get 31x plus 31 divided by 2 times 30, which is going to be 465. So a little algebra. And I get x to be 20. So how many push-ups do you do on March 1st? That is going to be 20 push-ups. So second one, radio stations giving away a total of $124,000 in August. If they increase the amount given away each day by $100, how much should they give away the first day? So again, you're looking for, there's a total, you're looking for an increase in the amount given away each day by 100 bucks. And how much should they give away the first day? So there's my sum. So the sum is going to be $124,000. All right, this is the SN. All right, my N is going to be the number of days in August. I think there's 31 days in August again. There is. There's 31 days in August. If they increase the amount given away each day by $100, so we're looking for the first day. Then on the 31st day, that'll be 100. So first day will be X. Second will be X plus 100 bucks. Third day will be X plus 200 bucks. Fourth day will be X plus 300 bucks. So on the 30th day, or on the 31st day, it'll be X plus $3,000. So that's kind of what we're looking at. So it'll be 31 over 2 times 2x plus $3,000. That's going to equal $124,000. So little algebra here says that this is going to be 31x plus 4,650. That's going to equal 124,000. So a little division, subtract 4650. Divide by 31. So the first day they should give away $3,850. That's how much they should give away on the first day. So find the sum of all positive odd integers less than 180. So if we're looking at this, all positive odd integers less than 180. So you're looking at every positive integer from 0 to 180. All right, so how many odd integers are there between 0 and 180? Well, if you just divide it by 2, there's 90 of them. So this is going to be 90 divided by 2. What's the first positive odd integer? 1. What is the last positive odd integer? What's smaller than 180? That's going to be 179. So the sum of this is going to be 45 times 180. So 45 times 180, the sum of the first positive odd integers from 0 to 180 is going to be 8100. All right, find the first three terms of an arithmetic sequence in which a sub 1 is negative 16, an is 33, sn is 68. So here you're trying to solve for n. You're actually trying to figure out, okay, my first term is negative 16. My sum is 68. And I'm trying to figure out what n is. Only thing I know is that this is negative 16, and the nth term is 33. So n divided by 2, negative 16 plus 33 is going to be 17. So that's going to be 17. So now, a little solving, 68 divided by 17 times 2. So n equals 8. So that means that my 8th term is 33. Okay, so now we got to kind of go back to arithmetic sequences a little bit. This is kind of where you use a sub n equals a sub 1 plus n minus 1 times my common difference. Except here, now I know that my 8th term is 33. My first term is negative 16. I need to figure out what my common difference is. So this is going to be 8 minus 1 times d. So add 16, add 16. So that's going to be 49. So my common difference is going to be 7. So that would be my common difference. That's kind of using that explicit formula a little differently. All right, sigma notation. Sigma notation is a fancy way of saying add all this up. So here's what it says. The bottom is n equals 1, top is n equals 10. So kind of the way that works is this. I put 1 in here first, then I put 2 in here, 3 in here, 4 in here, all the way up until I end up at 10. Okay, so kind of the way that works is this. If I want to figure out the sum, I can do this. So I can take 10 divided by 2. My first term is going to be 3 times 1. My last term is going to be 3 times 10. So my sum of the first 10 terms will be this. 5 times 3 plus 30. That will give me my sum. So I believe that's 165. So if I look at this, J starts at 5 and ends at 8. So I start at 5, I go to 8. That's 5, 6, 7, 8. That's 4 terms. Okay, so I'm going to take the sum of those 4 terms is going to be 4 divided by 2. Now, if I put 5 in here first, 3 times 5 minus 1 is 14. Now I put 8 in here. 3 times 8 minus 1 will be 23. There's what I'm solving. 14 plus 23 times 2. So my sum there is going to be 74. All right, suppose you email a joke to 3 friends on Monday. Each of those 3 friends sends a joke on to 3 of their friends on Tuesday. Each person who receives a joke on Tuesday sends it to 3 more on Wednesday. How many people have read it by Friday? So you start off with the 1 person. You send it to 3 people. 1, 1, 1. They send it to 3 people. They send it to 3 people. All right, so this is kind of being tedious. So what am I doing? I'm multiplying by 3 over and over and over again. So I multiply by 3 for the ones I send it on Monday, multiply by 3 more for sending it on Tuesday, multiply it by 3 for sending it on Wednesday, multiply it by 4, or by 3 by sending it on Thursday. So there is sending it out for the entire week. So by how many people have read it by Friday? 243 people. So now that would be an example of a geometric series. Geometric series, once again, geometric means you're multiplying or dividing. Series means you're adding them all together. So now focus in on this left one. This left one is a little bit easier to read, I think, where R is your common ratio, what you're multiplying or dividing by over and over again. A sub 1, first term. N is the term you're looking for. Okay, so this requires a little bit more work. So find the sum of a geometric series for which A1 is 1,000, AN is 125, and R equals 1/2. So the sum of the n, first term is 1,000. So I'm going to take 1 minus 1/2 raised to the nth power, because I don't know what n is, all over 1 minus 1/2. So I don't know what n is, but I do know that the nth term is 125. So here's where that explicit formula comes into play again. So a sub n equals a sub 1 times my common ratio raised to the n minus 1. So if I know that my nth term is 125, I know that my first term is 1,000 times my common ratio raised to the n minus 1. I can figure out what n is. So if I divide by 1,000, so 125 divided by 1,000 is 1/8. So 1/8, now here's where you got to kind of think about what times itself 3 times, what times, 1/2 times what, repeated gives you 1/8. Well, that's going to be 1/2 to the third power. All right, so that's why it pays off to be fluid and to know what you're doing in exponents. So 1/8 is 1/2 to the third power. So that means 3 is equal to n minus 1. So n equals 4. So n equals 4. So over here, I put 4 in for n. So I'm looking for the sum of the first 4 terms. So I'm going to do 1,000. 1 minus 1/2 raised to the 4th is going to be 0.9375 all over 1/2. So my sum is going to be 1875. All right, Maria arranges some rows of dominoes so that after she knocks over the first one, each domino knocks over 2 more. Then if there are 10 rows, how many dominoes does Maria use? So my common ratio is multiplying by 2. All right, so there's the first domino, that knocks over 2, that knocks over more. Each domino knocks over 2 more dominoes when it falls. So it goes 1, 4, 8, and so on for 10 rows. So I'm looking for the sum of the 10th. All right, so my first term is 1. My common ratio is 2, and I'm going to the 10th row over 1 minus 2. Okay, because I'm knocking down 2 each time. I'm going 10 rows. My first term is 1, so I've got to work all that out. So 1 minus 2 raised to the 10th is going to be negative 1,023. All that over negative 1. So after 10 rows, how many dominoes did I knock over? 1,023 rows, or 1,023 dominoes. All right, contagious diseases can spread very quickly, such as Ebola. Suppose 5 people are ill during the first week of an epidemic, and each person who is ill spreads the disease to 4 people by the end of the next week. By the end of the 10th week, how many people are going to be sick? Well, starts off with 5. They give it to 4 people throughout the week. So at the end of the 10th week, so I'm looking for the sum of the sick people at 10 week. 5 people started with it. They spread it to 4 people over the course of 10 weeks. So my common thing is 10. My time is 4. So I'm going to take 1 minus 4 raised to the 10th times 5. So that gives me negative 5,000. No, negative 5,242,875. Divide that by negative 3 because that's what 1 minus 4 is. So how many people have it? 1, 7, 4, 7, 6, 2, 5. About 1.7 million people are sick after 10 weeks. That's quick spreading disease. All right, that's all I got. Come talk to me with questions. This is not an easy section, so please do what you can to understand it.